Hey boys and girls, how's it going? We are on chapter 7, lesson 5, add and subtract fractions. Okay, so I just chopped 4 of them, and now that I look at them, there's only 1 add and 3 subtract. Interesting. Okay, that's okay though, right? Let's start here with number 4. We have 6/10 plus 3/10. Now you guys have been doing a lot of this, and you know that if we are working with tenths, then every size piece is the same. So we can just look at the 6 and the 3 and know that we have 6/10 and 3/10 and add that 6 and 3 together to get 9/10. Because remember, this doesn't change. That just tells us how many pieces make one whole. So we just keep that the same. That's what the denominator is for. All right, let's pop over here to number 5 and see how that looks. Number 5, it says 1 minus 3/8. We did one like this in the last homework, didn't we, on chapter 7, lesson 4. And what we thought about was that one whole. Okay, and that one whole, we can rename that, rewrite that, write an equivalent fraction for one whole. And remember over here we said how important it was that the size of the pieces are the same, that we have one whole separated into 10 equal parts for both? Well, how about we make 1 8/8? Why did I choose eighths? Because that second fraction has eighths. 8/8 minus 3/8, well, the one whole is made out of 8 equal parts. All the pieces are the same size, so I can just focus on the numerator. 8 pieces minus 3 pieces is 5 pieces out of 8. 8 minus 3 is 5. Beautiful. Okay, number 7. 9/12 minus 5/12. Well, denominator 12 and 12, so we can just look at the numerator. If we have 9 pieces and we take 5 away, 5, 6, 7, 8, 9, that is 4 out of 12 pieces left. Is this like the best few lessons or what? Let's look at number 8. 5/6 minus 2/6. Well, we have 6 that make the whole, so all the piece sizes are the same. So let's just look at the pieces we have. If you have 5 and you take away 2 pieces, you have 3 pieces out of 6 left. Fantastic. Let's keep going. Oh, now we have a table to work with here. Okay, I'm going to read number 10. Guy finds how far his house is from several locations and makes the table shown. So let's look at the table. Distance from Guy's house. So we have, oh, I see here, the library is 9/10 a mile away. The school is 5/10 mile away. The store is 7/10. Cafe is 4/10. Yogurt shop 6/10. That's how far those places are from Gary's house. All parts of a mile. So he lives less than a mile from all of those places. That's very close. So let's see what they're asking. Right here is where I'm reading now. How much farther away from Gary's house is the library than the cafe? Well, let's see here. The library is 9/10. The cafe is 4/10 mile away. So we did this before with a number line, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9/10 is right here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And what's the cafe? 4/10. 1, 2, 3, 4. Okay, so that's where they're the same distance away from Gary's house. Not Gary. What's his name? Guy. From Guy's house. And here is how much further away. And that is 1, 2, 3, 4, 5. It's 5/10 away. I mean, it's 5/10 further. 9/10. The cafe was 4/10. How much further? Gosh, my little jumps on the red line were not great. Okay. 1, 2, 3, 4, 5. That is 5/10. So the library is 5/10 mile further away than the cafe. Okay? So 5/10, I guess you would write the word further or mile. 5/10 mile. Okay. All right, let's check number 11. If Guy walks from his house to school and back, how far does he walk? All right, let's see here. The school right there is 5/10 mile away. So here's Guy's house. Here's the school. So from here to here, let's see, from his house to school is 5/10 mile, right? Going that way. But he walks there and back. So Guy goes to school and then he goes home from school, which is another 5/10. So he goes 5/10 this way and then 5/10 this way. So how much is that all together? 5/10 one way plus the 5/10 going the other way, right? Equals 10. Now what's our denominator? 10. 10/10, which you guys know is 1 mile. So he walks a mile every day when he goes to school. Half a mile to school, half a mile home. Because you know 5/10 is equivalent to half, right? Just throwing in a little extra. Okay, excellent job, boys and girls. Okay, let's take a look at the back. This is number 2 from the back of your paper. It says, which equation does the model below represent? Now, this reminds me of what we just drew when we were talking about how much further the library is than the cafe. Remember that? We were talking about how much further, and we said that that distance was, that was how much further. Okay? That was a subtraction problem, wasn't it? So let's look down at these choices. All right, so that's an addition. So no. Okay, so they are really comparing 1, 2, 3, 4, 5, 6, 7. 7/8, and they're trying to find the difference between 7/8 and 2/8. What's the difference between 7/8 and 2/8? Well, they're the same right up to there. And this is the difference. That's 1, 2, 3, 4, 5. So 7/8 minus 2/8 equals 5/8. So they're comparing two fractions to find the difference, right? And you know that difference is the answer to a subtraction problem. So that's what that model represents. So all subtraction doesn't have to have arrows taking things away. They can be comparing two different fractions to find the difference. Nice job. All right, now we are already down here on the review. Woohoo! All right, this is Chapter 4, Lesson 12. And it's number 3 in your review. Now let's read it together here. There are 6 muffins in a package. How many packages will be needed to feed 48 people if each person has 2 muffins? Oh my goodness, let me see here. I've got to go back. I've got to reread this. There are 6 muffins in a package, so I know that a package has 6 muffins. How many of those packages will be needed to feed 48 people? Okay, but each person has 2 muffins. Oh, so that's a little different right there. Well, let's see here. If 48 people each have 2 muffins, I think the first thing I'm going to do is figure out how many muffins are going to be needed altogether. So if 48 people each have 2, right? I'm going to have 48 sets of 2 muffins. So because 48 is the amount of people, and they each get 2 muffins, so it's 48 sets of 2 muffins. 48 sets of 2 muffins, right? All right, so let's see how many muffins we need all together. 2 times 8 is 16. 2 times 4 is 8, plus 1 more is 9. So we need 96 muffins. But that's not what they asked us, is it? They asked us how many packages. Okay, and remember what did we say up here? Each package has 6 muffins. So if I need 96, right? Put your arms out big. I need 96. How many sets of 6 are in 96? So pretend you're taking out 6. 1 set of 6. Another set of 6. Another set of 6. What operation is that, boys and girls? When we are figuring out how many equal sets are in a number. Ding, 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 ding. Division. Right? So that's the 96 muffins. Okay? Muffins. Whoop. 96 muffins. 6 per package. And so the quotient will be how many packages we need. All right, so let's divide. Does McDonald's serve cheeseburgers? I know you're tired of hearing me say that. And if you don't need that, you don't need to use it. You can just divide. Okay? So let's divide 6. We have 9 tens. So yeah, we can give 6 people each a 10, right? So 6 goes into 9 one time. Now multiply 1 times 6 is 6, right? S for subtract. 9 minus 6 is 3. So we have 3 tens left over. Now check. 3 tens, 6. Yep. 3 is less than 6. So we can bring down. Okay? And then we start all over again with division. I have 36. Can I share 36 with 6 people? I sure can. How many 6s are in 36? Do you remember your 6s pretty well? Okay. Oh, that's a terrible color. 6, 12, right? 18, 24, 30, 36. 1, 2, 3, 4, 5, 6. You've got it. You got it. 6 goes into 36 6 times. So 6 times 6 is 36. Subtract. You don't have any muffins left. So how many packages do you need to buy? Ringy ding ding. 16 packages of muffins. And everyone in your group of 48 people will get 2 muffins. Fantastic job, you guys.